Good day, viewers, and welcome to this class. Today we'll be looking at Post-UTME Physics Past Question compiled from many universities across Nigeria, and let's dive right into it. First question here says, a ball is thrown up into the air. At the highest point of its trajectory, the ball dash. Option A says the ball is accelerating downward. Option B says the ball has zero acceleration. Option C says the ball is accelerating upward. Option D says the ball is still moving upward. Now, when a ball is thrown vertically upward, it gets to its maximum point. When it gets to its highest point, the final velocity of the ball is zero. And at that highest point, please note that the acceleration to gravity is still acting downward. Despite the fact that the ball is at the highest point, the acceleration to gravity is still acting downward. So at that highest point, the ball is going to start decelerating downward. So because the ball is decelerating downward, that is what it is, accelerating downward, or it is moving downward. So the correct answer to this question is that the ball will start what? Accelerating downward. So that takes us to question number 2, which says a ball of mass 200 grams. So the mass of this ball is 200 grams, moving with a velocity of 8 meters per second. So this is M1, and it has a velocity U1 of 8 meters per second. And it collides and sticks with another ball of mass 300 grams. So I have a new mass, 300 grams, moving in the same direction with velocity 4 meters per second. So my U2 is 4 meters per second. And then it said, what is the common velocity of the ball after collision? What is the common velocity of the ball after collision? So I have my V is unknown. And now, according to the law of collision, that the total momentum before collision must be equal to the total momentum after collision. What is that saying? It means momentum before collision must be equal to momentum after collision. That simply means that I have M1 U1 plus M2 U2 will be equals to V open bracket M1 plus M2. So with this formula, we're going to solve this question. So all we have to do is impute. So this will give me 2 over 10 times my U1, which is 8, plus 3 over 10 times my U2, which is 4, is equal to my V is still V in bracket 2 over 10 plus 3 over 10. So this will give me 16 over 10 plus 12 over 10 is equal to V open bracket 5 over 10. So this is the same thing as saying that I have this is over 10, and this will give me 28 over 10 is equal to V in bracket 1 over 2. So this is giving me 28 over 10 is equal to V over 2, and that will give me 10V is equal to 28 times 2. And that divided both sides by 10, divided by 10. This means that my V is equal to, this will give me 56 divided by 10. That means that my V is equals to 5.6 meter per second. So the correct answer to question number 2 is 5.6 meter per second, which is option A. Moving on to question number 3, it says, a boy holds the end of a rubber cord from which hangs a solid metal ball. If the boy whirls the ball in a horizontal circle, keeping his hand still, if the rubber cord breaks when the ball is at a point on the circle, in what direction will the ball move? Now, when the boy is wheeling the ball, you discover that the ball will be moving around the circle using what? Centripetal force. So if this is a circle, the ball will be what? Moving around the circle using centripetal force. And that is because there is a string that is holding the ball in place within this circle. If this string cuts, the ball will no longer be what? Moving in that same direction, although the ball will still be moving along this same tangential. So it will be moving along the tangential path, but since the string has cut, it will start obeying Newton's first law of motion, which is the law of inertia. It will remain in a state of uniform motion. So the ball is moving in the direction of the tangent to the circle at the point of break. So the correct answer to this question is that the ball will be moving in the direction of the tangent to the center of the circle at the point of break. And that is what? Option C. So moving on to the next question, which is question number 4. It says, a force of 20 Newton applied parallel to the surface of a horizontal table is just sufficient to make a block of 4 kilogram set for motion. So in this question, we're told that what? The first force there was 20 Newton. And this force allowed the block of mass 4 kg to what? To move, to set for motion. So since it's setting the ball in motion, it means that this is what? Limiting frictional force. So this is what? Limiting frictional force. So because this is limiting frictional force, because if the amount of force that is needed to set a body in motion is what is called the limiting frictional force. So at that point, the body just starts to move. In this case, the block just starts to move. And then it said, find the acceleration when the force is doubled. So if the force is doubled, it means I'm applying a new force, which is what? 40 Newton. Double of the what? Frictional force. So if I'm to find the acceleration of this body, so the acceleration here is unknown. Now for me to find the acceleration, I have to find the net force. So my net force is supposed to give me the new force applied minus the frictional force. So this means that I have what? 40 minus 20 Newton. And that will give me 20 Newton. So I've gotten the force, the net force. But I know from Newton's second law of motion that force is equal to mass times acceleration. This simply means that acceleration is equal to force. In this case, net force now over the mass. So this is the same as saying that my acceleration, therefore, is equal to 20 divided by the mass, which is what? 4. And that will give me 5 meters per second. So the correct answer to this question is 5 meters per second, which is option C. So moving on to the next question, which is question number 5. It says a man walks 1 kilometer due east and then 1 kilometer due north. So if this man moves due east, so he moves due east 1 kilometer and gets to this point, and from this point moves due north another 1 kilometer. The question they're asking is, what is his displacement? So we're trying to find the displacement of the man. The displacement of the man. So in order for us to find the displacement of the man, this is the same as saying that I have to find the what? The distance between the starting point of the man and the current position of the man. And in what direction? So this is, if I bring this out, this is supposed to go this way. And then I trace this down to this point. So this angle here is my theta. And if here is 1 kilometer, automatically here will also be 1 kilometer. So I'll be having a triangle that looks this way. I'll be having a triangle that looks this way. So this is a rectangle triangle. Here is 1. This is also 1. And this is theta. So at this point, I will solve for that using that triangle to find the what? The displacement, the magnitude of the displacement, and then the direction. So with this, I can use what? Pythagoras theorem. Using Pythagoras theorem, I can tell them, therefore, that the displacement, let's call this place x as displacement. So my displacement square is equal to 1 square plus 1 square. And that will give me that my displacement is equal to 2. It means that my displacement square root of 2. So now that I've gotten my displacement as the square root of 2, I won't just stop there. I will also find the what? The direction. So the direction of this, if I want to find the direction is tan theta is equals to 1 over 1, which means that my theta is equals to tan inverse of 1, which means that tan inverse of 1 is 45 degrees. And if you discover that what this new position of this man is in between the east and the north, which means what I have is what? Northeast, which means that my direction here is north 45 degree east. And then my displacement is root 2 meters. And root 2 meters, you can also put it in decimals. If you put it in decimal, what you're going to be having is going to be 1.4, which is same as saying 1.41 meters. So it means that both the direction and the displacement is going to be 1.41 meters, not 45 degree east. So this is the displacement of the man. So the displacement of the man is supposed to be 1.41 meters, not 45 degree east. Looking at this, there's a typographical error. So the correct answer is supposed to be option C, where I'm supposed to have 1.41 kilometers, as in this case, kilometers, supposed to be kilometers, because what we are given originally was in kilometers. So this is kilometers. So 1.41 kilometers, not 45 degree east, which is option C. Moving on to the next question, which is question number 6. It said, a motor car moves with a velocity of 20 meters per second. So my initial velocity is 20 meters per second on a rough horizontal road and covers a displacement of 50 meters. So our displacement is 50 meters. Find the coefficient of dynamic friction between the tire, not type, and the ground. So we are looking for the word coefficient of dynamic friction, which is mu. And then we're given G as 10 meters per second square. Supposed to be 10 meters per second square there. So with this, all we have to do is to find the word acceleration using Newton's equation. So looking at that, all we have to do is tell them that what v square is equals to u square plus 2ax, as in this case. So this is the same as saying that I have my final velocity at that point is going to be what? 0, because the car is going to what? Be coming to rest. So this would mean that I have what? 0 is equal to 20 squared plus 2 times a times 50. This is the same as saying I have 400. 0 is equal to 400 plus 100a. So if I move this to the other side, it means that I have minus 100a is equals to 400. So divide both sides by minus 100 divided by minus 100. It means that my a is going to give me minus 4 meters per second squared. Now with this, I know that a is also equal to minus mu g. So this is the same as saying that I have minus 4 is equal to minus mu times 10. So if I divide both sides by minus 10 divided by minus 10, minus will cancel minus, 10 will cancel out 10. It means that my mu is going to give me 0.4. So the correct answer to this question is 0.4, which is option D. Moving on to the next question, that's question number 7. It says, a physics student standing on the edge of a cliff throws a stone vertically downwards with an initial speed of 10 meters per second. So my initial speed was given as 10 meters per second. The instant before the stone hits the ground below, it is traveling at a speed of 30 meters per second. So my final velocity was given as 30 meters per second. If the physics student were to throw the stone horizontally outward from the cliff instead with the same initial speed, so my initial horizontal speed was given as 10 meters per second. What is the magnitude of the velocity of the stone just before it hits the ground? So now the first thing I'm going to do here is to find the height of the cliff. And for me to find the height of the cliff, it means that I'll tell them that v square is equal to u square plus 2gs. or let me say h, as in this case. So my final velocity was given as 30, so I have 30 squared is equals to 10 squared plus 2 times 10 times h. So this will give me 900 is equals to 100 plus 20 h. So this will give me 900 minus 100 is equals to 20 h. That will give me 800 is equals to 20 h. Divide both sides by 20, divided by 20. This means that my h is equals to 4. This will give me 40. So I have 40 meters. Now that I've gotten the height, I will use this to find the what? The vertical speed of this particular rock when it is thrown horizontally. And for me to do that, it means I have to look for my what? Vy. So with this, I know that my Vy is supposed to give me 2gh, square root of 2gh. How did I get this? You know that v squared is equal to u squared plus 2gh. Now at this point where you are throwing it horizontally, you are starting from rest because it's throwing it horizontally. So my initial velocity of throwing it is going to give me 0 at that point. So what I'll be having here, it means I'll be having what? Vy. So I have Vy squared is equals to 2gh. This is same as saying Vy is equals to square root of 2gh. So it means therefore that my Vy is equals to 2 times 10 times the height, which is 40. So that will give me square root of, that will give me 800, square root of 800. So I have square root of 800. That means that my Vy is equal to 28.28. So with this, I'll now find the velocity with which it hits the ground, and that is saying that my velocity with which it hits the ground is equals to square root of v ux. So this is ux, uy, and ux. So this means that my ux square plus uy square. So this means that my final velocity before it hits the ground is going to give me 10 square plus 28.28 square. That's the same as saying that I have 100 plus 800, and that will give me square root of 900. That will give me 30 meter per second. So at the end of the day, the velocity, the magnitude of the velocity of the stone just before it hits the ground is going to be 30 meter per second, which is option C. So that takes us to question number 8, which says a quantity is defined as the product of cross-sectional area. So we have cross-sectional area times change in momentum per unit length. What this simply means is that I have area times momentum over length. So we have to find the SI unit of this particular quantity. We know that our area is measured in meters squared times momentum is the product of mass and velocity, which means I have mass times, mass is measured in kilogram, so I have, this is mass times velocity over length. So this is same as saying I have meter squared times mass is measured in kilogram times velocity is measured in meter per second. So length is also measured in meters. So meters here will cancel out meters. So at the end of the day, what I'll be having is kilogram times meter square per second, which is the same as saying kilogram meter square per second. So our unit is supposed to be kilogram meter square per second. So we are looking for the option that has kilogram meter square per second. Looking at all of these options, the closest one, there's a typographical error, I think. Option C here is supposed to be kilogram meter square per second. So which would have been our correct answer. So the correct answer is kilogram meter square per second. Next is question number 9, which says a rectangular concrete block with the dimension. So the dimension was given as 40 centimeters by 30 centimeters by 60 centimeters. This is the same thing as saying I have 0.4 meters by 0.3 meters by 0.6 meters. So, and then it said of mass, so the mass was given as 10 kilogram. That it rests on the horizontal flat surface. What is the minimum pressure? So we're looking for the minimum pressure. We do not know. We know that our G is supposed to be 9.8 meter per second square. Why are we using 9.8? Because it was not given in the question. So whenever it is not given, you use what? 9.8. But if it is given, use the given value. So now, whenever the area of a surface is maximum, the pressure is minimum, because we know that what pressure is equal to force over area, which is the same thing as saying that mass times acceleration to gravity over area. So when my area is the highest, then the pressure will be the minimum. So I will look for the dimension or the value of my area in which my area will be the highest from this dimension, and in order to what, make my pressure minimum, and that will be 0.4 times 0.6. So this face of this block, when this face of this block is resting on the flat surface, that is when the pressure will be minimum, as the what area would be maximum. So this will give me 0.24 meters squared. With this, I know that my pressure therefore will be equals to, this will give me 10 times 9.8 divided by 0.24. So this will give me 98 divided by 0.24, which will give me that my pressure therefore is equals to, that will give me 98 divided by 0.24, that will give me 408.3 Newton per meter square. So the correct answer to this question is 408.3 Newton per meter square, which is option C. So the unit here is supposed to be Newton per meter square. That is the next question, which says, that's question number 10, which says a simple hydrometer consists of a uniform cylinder suitably weighted to float upright in the most common liquid. It is graduated to read the relative density of a liquid directly. Which of the following is not correct? Option A says, when placed in a liquid, it displaces exactly its own weight of the liquid. It displaces exactly its own weight of the liquid. Option B says, its graduation increases from the top to the base. Its graduation increases from the top to the base. Option C says, when placed in a liquid, it displaces exactly its own volume of the liquid. And option D says, the product of the volume and density of the liquid displaced is equal to its mass. Now let's start explaining each one of these. Now the first one that says, when placed in a liquid, it displaces exactly its own weight. It displaces the weight that is submerged. The weight that is what? Submerged. So it displaces exactly its own weight is partially correct, because it displaces the weight of the liquid that is what? Submerged. Then option B says it is graduated, its graduation increases from top to the base. Its graduation does not increase from the top to the base, it decreases from the top to the base. So the highest graduation, or the highest value of the graduation, ought to be at the top, so that when it is submerged inside the liquid, you can easily read the density of the substance. Option D says, when placed in a liquid, it displaces exactly its own weight of its own volume of the liquid. it does not displace exactly its own volume of the liquid. It does not displace exactly its own volume of the liquid. It displaces the weight of the liquid, its own weight of the liquid. So the volume, the quantity of the liquid that is displaced is equal to its weight, not equal to its volume. So, and then the last one says the product of the volume and density of the liquid displaced is equal to the mass. We know that what? Density is what? Mass over volume. So when you multiply volume, times density, it's the same thing as saying that I have what? Volume times mass over volume. So volume will cancel out volume, so that particular option is actually correct. But the question is asking which of the following is not correct. So the correct answer to this question is supposed to be option C and B, but option C here is talking about what? Its volume that is displayed, which is also partially correct as it's related to the mass of the body that is what? Mass of the substance that is what? Displaced. So the correct answer to this question is option B. The graduation starts from the increases from the top to the base, which is what? Wrong. So because the graduation what? Decreases from the top to the base. Moving on to the next question, which is question number 11. It says a stone which is dropped into a dry well hits the bottom in 2.2 seconds. How deep is the well? So the time it takes the stone to hit the bottom is 2.2 seconds. Then they're asking that how deep is the well? So we're looking for the word depth or height of the well is unknown, and we're given G in the question as 10 meter per second square. So we know from Newton's equations of motion, we know that what? Our height is equals to ut plus half gt squared. So in this case, this is same as saying that because this stone was dropped from a height, it means that the initial velocity u is 0 meter per second. So which automatically means that my h is equal to what? 1 over 2 gt squared. This means that my height is equal to 1 over 2 times 5 times 2.2 squared, which is same as saying 1 over 2 times 5 times 2.2 squared here will give me 4.84. So when you multiply and divide by this, you are going to get 24. So this will give me times 5. That will give me 5 times 4.84 divided by 2. That will give me 24.2 meters. This is supposed to give me times 10 times 10. So that will give me 24.2 meters. So at the end of the day, our correct answer to this question is option D, which is what? 24.2 meters. Moving on to the next question, it says, question number 12 says, a woman whose mass is 70 kilogram. So our first mass was given as 70 kilogram, sits 2.4 meters from the fulcrum of a seesaw. So the distance x1 is 2.4 meters. So at what distance from the fulcrum should a 60 kilogram man sit to balance the seesaw? So we have our M2 as 60 kilogram, and we are looking for X2, we do not know. So if this is a seesaw, and I have my fulcrum, I have a woman sitting here, and she is 70 kilogram, and the distance between the woman and the fulcrum is 2.4 meters. I have another man sitting here, and he's 60 kilogram, and his distance is x2. I do not know. So I'll take my moment to the pivot, tell them that anti-clockwise moment is equal to clockwise moment, the principle of moment. So this is similar as I have 70 times 2.4 is equal to 60 times x. So times x2 in this case. So this will give me 70 times 2.4. That will give me 168 is equal to 60x2. Divide both sides by 60 divided by 60. It means that my x2 is going to give me 2.8 meters. It means that the man, the 60 kilogram man, will have to sit at what? The 2.8 meters point from the fulcrum, and that is option A. Moving on to the next question. Question number 13 says, an air bubble trapped at a depth in a liquid rises to the surface. Which of the following is true about its mass and density as it rises? Now, what I'm saying in this question is that there's an increase in the what? Volume of the air bubble. And we know that density is mass over volume. Now, remember in the question, they did not say that an additional air bubble was added. There is no increase in the mass of the air bubble. The mass remained the same. So the mass is what? Constant. But the what? Volume increased. As the volume is increasing, if you notice, density and volume are inversely related, which means that an increase in the volume as the what? As the air bubble rises, what will happen to the density? The density what? Will decrease. Why the mass will become what? Constant, because there is no what? Additional mass that was what? Added. So we're looking for the option that has to do with what? Constant mass and what? Decrease in density. So the question is, which of the following is true about its mass and density as it rises? Option A says its mass and density increase, which is wrong. Option B says the mass is constant while its density decreases. The mass is constant while the density decreases, which is the correct answer. That is option B. Moving on to the next question. Question number 14 says, complete the following sentence. The operation of a hydraulic jack is an application of dash. Please note that the operation of a hydraulic jack or hydraulic press is with what? Is the application of Pascal's principle that talks about even distribution of pressure in a fluid. That is option A. The next question, question number 15 says, complete the statement. Today, the standard meter is defined in terms of what? Please note that the standard meter is defined in terms of the speed of light. So the standard meter is defined in terms of 1 over 3 times 10 raised to power 8 meter per second. So this is the standard meter definition, and it is what? In terms of the speed of light, which is what? Option D. Moving on to question number 16, it said convert 30 meter per second to centimeter per minute. So we have to convert 30 meter per second to centimeters per minute. So the first thing we are going to do is to convert it from meter per second to centimeters. So when you are converting from meters to centimeter, you multiply by centi, which is the same as saying I have what? 30 times 10 raised to power 2. So if I divide, let's say I divide by centi here, which is divided by 10 raised to power minus 2, which is the same as saying that I have 30 times 10 raised to power 2. And that will give me 3,000. So I have 3,000. So I have 3,000 centimeter per second. So it is still in per seconds, and in the question it says you convert it to what? Per minute. In order to convert from seconds to minutes, you what? You also multiply again by 60, because it takes what? 60 seconds to make 1 minute. So this will give me this 3,000 times 60, and that will give me 3,000 times 60 will give me 180,000 centimeters per minute. So at the end of the day, our correct answer is 180,000 centimeters per minute, which is option B. Moving on to the next question, which is question number 17, says, during a football match, player A kicks the ball 40 meters 30 degrees east of south. So our displacement for the first kick was given as 40 meters south 30 degree east. And then for the second kick, this is first kick. So player B, who instantly kicks it, so player B kicks it. So our second kick, our displacement was given as 30 meters north 60 degrees east. Then we have to find the magnitude of the resultant displacement. So the first thing we have to do is to resolve the first kick into the horizontal and vertical component. So this means that for first kick, my x1 is going to give me, let's call it x1 because it's first kick. So that will give me x sine theta, and that will give me 40 sine 30, which will give me 20 meters. And then I have my y1 as x cos theta, which will give me, that's minus x cos theta, that will give me minus that will give me minus 30 minus 40 cos 30, and that will give me, that's cos 30 is 0.8660 times 40. That will give me minus 34.64. So for the second kick, what I have, my x2 here is going to give me x sine theta again. So this will give me 30 sine 60, and that will give me 30 sine 60 times 30. That will give me 25.98. So my y2 is going to give me x cos theta, and that will give me that my y2 is 30 times cos 60, and that will give me 15 meters. So I will resolve my y and my x, so I have resultant of x, and that will give me 20 plus 25 plus 0.98, that will give me 45.98 meters. And then my x, my y will also be resolved, so I will have minus 34.64 plus 15. So that will give me 19.64. So my total resultant will give me the square root of rho x squared plus rho y squared, and that will give me the square root of 45.98 squared plus 19.64 squared. So I have 45.98 squared, 2114.16 plus 19.64 squared, 385.7273. So I have 211. So I have the square root of 2499.88. So my resultant is going to give me 49.998, which is approximately equal to 50 meters. So our correct answer to this question is 50 meters, which is option C. The next question, question number 18, says, how much work is done against gravity in sliding a 500-gram object through 2 meters up a smooth plane that is inclined at 30 degrees to the horizontal? So we are given the mass as 500 gram, which is equivalent to saying I have 0.5 kilogram through a distance. So we have the distance, which is same as height, as 2 meters, and then we have our angle of inclination as 30 degrees. So we have G as 9.8 meter per second squared, and we know that the work done in an inclined plane is equals to mgh sine theta. So this is the same thing as saying that I have my work done to be equals to 5/10 times 9.8 times 2 times sine 30. So this is the same thing as saying I have 5/10 So times 9.8 times 2 times 1 over 2. So it means I have 5 times 9.8. So I have 49 divided by 10, which will give me 4.9 joules. So the correct answer to this question is 4.9 joules, which is option D. Next question, which is question number 19, says if a small body of mass m is moving with angular velocity in a circle of radius r, what is its kinetic energy? We know that velocity in a circular body is equals to omega r, where omega is my angular velocity, my r is the radius, and v here is the velocity or linear velocity. So we know that kinetic energy is equals to half mv squared. Since my v is equals to omega r, this is the same as saying that my kinetic energy is equals to 1 over 2 times m times omega r or squared, which will give me 1 over 2 m omega squared r squared, or you can arrange it alphabetically such that I'll have 1 over 2 m r squared omega squared. So this is the formula for calculating the kinetic energy of a body in a circular path. So none of the options here has this, so but this is the correct answer, which is what? Half m omega squared r squared. And none of these options here has that. So I believe that the options here are typographical errors. So the correct answer is half m omega squared r squared. That takes us to question number 20, which says, in free fall, two balls of masses 20 kilogram and 10 kilogram were dropped from a height. If the ball with the smaller mass reached the ground after 4 seconds, what is the difference between the time the two balls reach the ground? Now, according to Sir Galileo Galilei, whenever two bodies are dropped in free space or dropped in space or in a vacuum where the effect of any forces cannot be felt, irrespective of their masses, they will get to the ground at the same time. So the ball of mass 20 kilogram and mass 10 kilogram are supposed to get to the ground at the exact same time, which means that there is no difference in their time of getting to the ground. The time it takes for the balls to reach the ground is actually 0 seconds because they will both get to the ground at the same time. So the correct answer to that question is option C. So thank you for staying with us and watching till this very moment. If you have a question, drop it in the comment section. Don't forget to subscribe and turn on your notification bell so that you'll be notified when we drop a new video.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Kakao,